So in the previous video, we talked about how to use a rearranged form of the ideal gas law to solve for the density of a known gas. Doing a little bit of algebra with that equation allows us to solve for the molar mass of a gas. And that can be helpful in particular if you have an unknown gas and you are able to determine its density, but you want to determine its molar mass. If you know that unknown substance's density, temperature, and pressure at those set of conditions, you can calculate its molar mass in grams per mole. And so that's another application of the gas law that you need to know and be able to do calculations with. So in this example, we have a sample of a known mass placed in a flask. It has a given pressure at this temperature, and I want to know what the molar mass of the compound is. Remembering that molar mass is in grams per mole, I look at what I'm given and I say, hey, I already know my mass. I know my mass. So I'm halfway home. I just need to know the moles, but I can also use this calculation or this equation of the ideal gas law to find molar mass. But you may say, wait a minute, I don't know the density of my gas. I didn't give you the density. But I did give you the mass and I did give you the volume. So, I can find the density of that gas as long as I convert it into grams per liter, not milliliter, which is what is done down on here. So I have organized the data that I was given. Before plugging things in to find the molar mass of the compound, I found my density by taking the grams and dividing by the given volume in liters. My density has to be in grams per liter because I need the liter from the ideal gas law constant to cancel with that density. I need my pressure obviously to be in atmospheres and my temperature to be in Kelvin. So those conversions I've done with the appropriate conversion factor and the given information. And so now I have a pressure, a temperature in Kelvin, gas constant, and density. I can now start to plug those into the rearranged ideal gas law to solve for molar mass. And doing that again, I'm going to make sure all my units cancel. My atmospheres cancel, my Kelvin cancels, my liters cancel. I'm left with grams per mole. That's great. That's a unit of molar mass. Doing that multiplication and division should give you a final answer of 102 or 102.1 grams per mole. So being able to determine the molar mass of a gas is another application of the ideal gas law that you should know and be able to do for the upcoming exam.